Hi everybody. We're going to talk a little bit today about 2.14, but before we do that, I want to do a quick warm-up. So if you get your notes out, and there, right after we finished our 2.13 notes, there's a page that says looking for question mark. I'd like to go to the back of that and just do a quick review to get ourselves warmed up and back in logarithm and exponent mode. So here we go. It says solve for x. Again, this is review. This should be easy for you. So we're going to log roll this. 49 to the 1/2 is x. That means the square root of 49, which is 7. Next, we're going to solve this little exponential, so we'll subtract 10, and then it becomes a no-brainer. X is 2. I told you this was easy. Now, this one we're going to need a calculator for. You'll see why. We're going to subtract the 5. But now, unlike this problem, we can't get a common base. 36 is 6 squared, so that's why we could just say x is 2. Here we're going to need a calculator, so we'll ln both sides, take the natural logarithm of both sides. So x plus 1 equals ln 15, and x will be ln 15 minus 1. Be careful when you type that into your calculator. If you type ln 15, you got to close those parentheses and then subtract 1. So your answer is 1.7081. All right, number 2. Again, these are review. Number 2, solve this logarithmic equation. Well, we've got a handy dandy log on both sides. So since ln 2x minus 2 equals ln 11, 2x minus 2 must equal 11. 2x equals 13, and x equals 13 halves. Absolutely nothing, no issues there. Next, we got a little exponential. 2 to the x squared minus 6 equals 8. Now, unlike this one that I'm erasing right here, we do not need logarithms. You could use logarithms, but you don't need them because 8, as you know, is 2 cubed. So, x squared minus 6 equals 3, x squared equals 9, and x equals plus or minus 3. Number 3. All right, now things are getting a little bit more complicated here. Not hard, still review. We got to pay attention to what's going on. So first of all, we got to pay attention to this right here. That becomes an exponent. Remember, a coefficient in front of a logarithm is an exponent on the thing you're logging. Now, we cannot, and you know this, we cannot solve a logarithmic equation if we have 2 logarithms on the same side. So I'm going to have to combine these. Since that's a subtraction, I'm going to put these 2 together as a division problem. That is one of your very important properties of logarithms. So we're going to put that together as a division. And then, actually, we can simplify that if you wish. So the log base for 1 over x equals 1. And then we can log rule that. So 4 to the first equals 1 over x. So 4x equals 1, and x equals 1/4. So good review here, lots of properties of logarithms that we absolutely can't forget. Remember, this chapter is a third of the course, so we have to remember all of our properties of logarithms. All right, use your graphing calculator to solve this equation. Now, I want to first of all, I want to solve this algebraically, okay? And then we're going to use our graphing calculator. We're going to graphically solve the equation. But I want to be sure that you're comfortable both ways. So if we're going to do it without graphing it, we're still going to need a calculator, but without graphing it, e to the 1 minus x equals 25/6. And then we can ln both sides. So 1 minus x equals ln 25/6. And x equals 1 minus ln 25/6. If I move the x over here and move the ln over here. So I'm going to do this in a minute by graphing, but I'm going to see what my answer is supposed to be. If I did this right, I should come up with negative 0.4271. Okay, now let's do it on our calculator. It makes no difference at all, but my personal preference is to go ahead and divide by 6. I'm just kind of programmed to do that. So I'm going to have an equation that looks like this. And then I'm going to go ahead and type this in as, clear out the old stuff. I'm going to type that in as e, this is y1, this is my first equation, e to the 1 minus x power, and then 25 divided by 6 as my y2. I've been doing weird stuff on my calculator, so I'm just going to zoom 6 for a standard window. Obviously, you can use lots of different window sizes, but I'm just going to zoom 6 it. And I come up with what I expect to see. Here's my line, 25/6, and then here's my exponential equation, which is exactly what I would think I would have with a negative exponent. That's a decay. Okay, that's the point I want. So, second calc intersect. Here's my first curve, my second curve, and lo and behold, that point right there is negative 0.4271, comma 25/6. I'm solving for x, so that's my coordinate that I'm looking for. All right, beautiful. We did that both ways. Obviously, you don't have to do it both ways. You just have to follow the directions. And finally, this is a good review problem. We had something like this on a quiz, I believe. Here's my original equation, little exponential, and I'm going to find the inverse of this. I'm going to find the inverse. So I'm going to switch my variables. Now, some of you struggled a bit with this, so especially since you've been away from it for a while, pay close attention, rewind me, do it again if you need to. I'm going to add that 5 over. And now I'm going to log both sides because my job is to get that y to y equals. I need to solve for that. The only way to do it is to take the log of both sides. And since that's a 3, I'm going to make my life easy, and I'm going to log base 3 both sides. Because when I do that, when I log base 3, a 3, that goes away, and I'm just left with 4y minus 1. The log base 3 of 3 is 1. They cancel each other out. Just like the log base e of e is 1, ln e. This is the same thing. All right, so I add 1. And divide by 4. So my inverse is the log base 3 of x plus 5 plus 1 over 4. Perfect. All right, let's go to the notes for 2.14 now. I really want you, especially since you're kind of on your own here, I want you to read through these notes and make sure you understand what he's trying to explain there. It's very clear, self-explanatory, not difficult at all. But let's just make sure that all of our I's are dotted and our T's are crossed. So let's read through that. I'm going to skip straight to example 1. And it says, we have a logarithmic function, and we know 2 points. Here's the form we're using. And we know 2 points on our curve are 2, 3 and 5, 7. We have a little table there. And we're going to write 2 equations that can be used to find the A and the B in my equation. My job is to write this equation. So I'm doing what I do with lines. With lines, I find M and B. Well, now I'm going to find my A and my B for this format. So, obviously, one equation will be 3 equals A plus B ln 2. That's X. That's Y. And the other equation will be 7 equals A plus B ln 5. So when it says, write 2 equations that can be used to find the values of A and B, there they are. You get your 2 equations by plugging in your X and your Y. Just like we did with our exponentials, just like we did with our quadratics, just like we did with all those things. Plug it in. All right, now B says, find the values of A and B. Now, one option you have is to go back to Stat, Edit, put in these 2 points, and do a logarithmic regression. Another option is to do this by hand. So in our next example, we're going to be doing it with the regression. So this one I'm going to go ahead and do by hand. But remember, unless you are told otherwise, regression is always a possibility if you have data points and you're asked to write an equation from those data points. But I'm going to do this one by hand just to practice. So first thing I notice is I can get A by itself in both of these equations. So 3 minus B ln 2 is A, and 7 minus B ln 5 is A. And then I can set them equal. So I have an equation that looks like 3 minus B ln 2 equals 7 minus B ln 5. Now, you may not like the looks of that equation, but it's very easy to solve. There's only one variable in it. We're just going to get that variable by itself. So let's do some rearranging. Move the 3 over here. So if I subtract the 3 over to here, that's going to be a 4. And if I add my BLN 5 over here, I'm going to have B ln 5 minus B ln 2. Okay? Now let's pull out that B. Running out from here. Let's pull out that B. So I have B ln 5 minus ln 2 equals 4. And then if you look here, you don't have to do this, but look, you have a log minus a log, and we know that means a division. So this is B ln 2.5. So B is 4 divided by ln 2.5. That's my B value. So I will just figure out what that is. 4 divided by ln 2.5. So B, come up here, B is 4.3654. Okay? Now remember, this was A. So I'm going to take 3 minus my answer that I just got, so second answer, times ln 2. And I got for A, I got negative 0.0259. So my equation Remember, it was supposed to look like this, so my equation is L of x equals negative 0.0259 plus 4.3654 ln x. Okay, so again, they gave us the format of the equation. This is our logarithmic equation. We plugged in our x's and y's. I solved for a so that I could set my two equations equal to each other. Did some rearranging to get b by itself. And again, this step is not necessary. You could do 4 divided by this parentheses and get the same answer. I just did that because it's less typing in. Plus, it's good practice with our exponent properties. Okay. Example 2. Now we have all this data, and we're going to use the regression capabilities of our calculator to find a logarithmic function model for the data above in this form. So we're looking for exactly the same form as we were before, different letters, but the idea is the same. Where P is the church size, so that's X, and Y is or S of P is the salary, so that's Y. All right, let's type them in. So we're going to stat, edit. Remember, you want to clear out the old, or if you, I don't know what you got in there, you can actually type over if you want to. All right, so let's put in all these numbers. I do want you to get in the habit always of storing that regression equation, you know, just like we did before. Is what I came up with. Okay? So hopefully you did too. If not, one of us made a mistake. So we need to double check. I wish you were here so we can check each other right now, but I'm going with this right here. If it's wrong, I apologize. You know what to do, you know how to do it. I hope I didn't type a number incorrectly. All right, part B. Using the model found in part A, what is the predicted salary in thousands of dollars for a pastor whose church size is 500 people? So in other words, we want P to be 500. Now, I do not want you to type, I don't want you to type this in and put 500 here. That would work, but you're gonna have unnecessary round off. So use your Y. You have stored this equation as Y. So Y of 500, and you should get So what does that mean? That's a salary, that's a Y value. That's a salary in thousands of dollars. So that salary is $94,329.54. That's how much that pastor should make for a church with 500 people. Okay, pretty easy, not bad. Okay, one more. Okay, decibels, sound intensity. So I is watts per, that's the intensity, so watts per meter squared. And B is the decibel level for that particular intensity. Okay, so there's your equation. So your decibels, I'll use their notation. This funky looking B is the Greek letter beta. Feel free to use B if you'd rather, that's not going to be a problem. Okay, so what are my two equations? Just like before, what are my two equations? Okay, so 70 equals A plus B log, what goes with 70? 10 to the negative fifth. Now I know that's 1 times 10 to the negative fifth. Feel free to include that in 1 if you want, but I'm not. I'm just going to say 10 to the negative fifth. One thing I do want you to notice about this though, guys, and this is kind of important, the base in this problem is not ln. These regressions we did on our calculators were ln regressions. This is a log, which means its base is 10. So this equation includes the log base 10 of 10 to the negative fifth. This is just negative 5. That right there is just negative 5 because log is base 10. And log base 10 of 10 to the negative fifth is negative 5. Again, one of your properties, you simply got to know them, okay? That's negative 5. So that equation is 70 equals A minus 5B. That's not a bad equation at all, considering what it looked like when we started. Okay, what's the second one? 120 equals A plus B times 1, log 1. Log 1. Wait a second. What's the log of 1? What's ln 1? What's log base 5 of 1? Any base, the log of 1 is 0. So this says 120 equals A. So here are my two equations. It says write two equations. Here they are. There are my two equations. Finding the values of A and B are easy. A is already 120. So 70 equals 120 minus 5B. So negative 50 equals negative, looks like B is 10. So my equation, well, it doesn't say, I'll go ahead and write my equation. It says find the values of A and B, there they are. Which means my equation is 120 plus 10 log I. So then the last problem, the human eardrum can burst when you get to an intensity of 10 to the 4th. According to the model, what is the predicted number of decibels required to burst a human eardrum? So we go back to our equation. This is your decibels, remember? So we're going to plug in. We're going to find our decibels. When we plug in 10 to the 4th. Now, boys and girls, what's the log of 10 to the 4th? LOG. What does this equal? The log of 10 to the 4th is 4. So this says 120 plus 40, so 160 decibels will burst the human eardrum. All right, we're almost done. You're almost done. Next page, backside. Next page, backside. Check your understanding. Here we go. I'm not even going to try to pronounce that word, but it's the Dayquil chemical. Has a half-life of 3 hours. Okay, this is a blast from our past. Suppose you take a single dose, which has 20 milligrams of this stuff. Write a function for g of h. It gives the number of milligrams remaining after h hours. Now remember, you're starting with 20 milligrams. And you are halving that, cutting that in half, every 3 hours. So in 3 hours, you'd have 10. But in 2 hours, that is not a whole half-life. That would only be 2/3 of the half-life. So our exponent is h over 3. H over 3. So if you have h is hours. So if you have 3 hours, that would be 1, and you would have 20 times a half. If you had 6 hours, that would be 2, and you'd have 20 times a half times a half. But if you only had 1 hour, that would be 20 times 1/2 to the 1/3. After how many hours will there be only 5 milligrams left? Well, we kind of just talked about it. After 3 hours, we'll have 10 milligrams left after 3 hours, cut it in half. After another 3 hours, so 6 total, we'll be down to 5. Because to get from 20 to 5, you have to cut in half twice, which means 2 half-lives, which means 6 hours. Okay, now that one was easy because 5 is 20 times a half times a half. Okay, look at the next one. After how many hours will there be 16 milligrams left? Okay, this is not going to be so easy. Go back to your equation. 16, and we want to know how many hours that's going to take. So let's divide by 20. Is that 0.8? I feel like I should know that. I'm going to use some decimals here to make my life a little bit easier. Obviously, I'm going to need logarithms, so I don't care. You can ln, you can log, do whatever you want. I don't care. I'm just going to log. So log 0.8 equals h over 3 log 0.5. Now, nothing cancels here. Nothing cancels, but you do pull the power off out in front. So log 0.8 divided by log 0.5 equals h over 3. So all we have to do is type that in. Don't forget your parentheses, guys. And then times by 3. So after how many hours was the question? Looks like about 0.9658 hours. So almost an hour. Almost an hour. Write a function that gives the number of hours until g milligrams of the initial dose remain in your system. it gives the number of hours until G milligrams remain in your system. So we want to have G milligrams in our system, and we want to know how many hours that will be. Now this is very strange looking because we're not used to seeing that, but remember, this is your format. This is the number of hours. This is how much you have left. So it says you have G grams, and H of G gives the number of hours. Well, let's divide by 20. And the only way to solve that, is to use logarithms. So the log of G 20th is H of G times the log of 1/2. Remember now, as messy and horrible as that looks, your job is to write a function H of G. So what is H of G going to look like? Well, it's going to be the log of G 20th, that's a G, divided by the log, I'm having a hard time with my markers today, the log of 1/2. Now, I don't like the looks of that any better than you do, but here's the deal. You want to know how many hours it takes? You simply plug however many grams you have in that equation right there. It's exactly what we did right here. It's exactly the same thing that we did over here. Look, log of 0.5, log of 0.5, log of G over 20, that was 16 over 20. So basically, we were finding the inverse of this exponential equation. Okay. And finally, number two. A logarithmic function, okay, so here's what our function looks like. And we gotta find A and H. Now, we know that it has an x-intercept at 4. Now, keep in mind what that means, you guys, is if the x-intercept is 4, that means if you plug in 4, you get 0. Now, in a logarithmic situation, how do you get 0? The log of what is 0? Well, the log of 1 is 0. So when I look at my equation here, and I need, let's see, what else do I need? Oh, and I need to get 4, I need that to be my intercept, then my asymptote has to be at 3, because 4 minus 3 gives me 1, and the log of that would be 0. So, I know that my H value, my horizontal shift, is 3. I feel like I was a little confusing there. Let me try again. Your normal logarithm has an intercept at 1. 1 comma 0 is your x-intercept. If you want your x-intercept to be at 4, you're going to shift it 3 units to the right. And how do we do that in an equation? X minus 3. Okay. So that part's easy. All right, what's next? Passes through the point 11, 6. So 6 equals A log base 2, 11 minus 3. I'm just plugging in my point. X is 11, Y is 6. So 6 equals A log base 2 of 8. Wait a minute, guys. That's not some random generic thing. What's the log base 2 of base 2 of 8 is 3. So 6 equals A times 3, which means A equals 2. And your equation is f of x equals 2 log base 2 x minus 3. And that's it for the page. Okay, so that takes care of that. I'd like you to do that 2.14 homework. The papers are posted in Schoology, so let me know if you have any trouble getting those, but I'd like you to get that done and have that ready to go when we come back to regular school. Not J-term school, but regular school when we come back. Okay, thanks a lot.